వినిపిస్తుందా?
Yes, sir.
Okay. So next one is the types of railway services. Okay. Next topic is types of services. Generally, railways are generally it's categorized into three types. Okay. First one is city or urban services, and second one is suburban services, and third one is mainline services. Okay. Types of services are classified into three types: urban services or city services, suburban services, and mainline services. Okay. So first one, what is a urban or city services? Generally, in this type of service, there are frequent stops. Okay, in this type of service, there are frequent stop, and the distance between the stops is nearly 1 kilometer or less than 1 kilometer. That type of services is called urban or city services. Okay, now we don't have to achieve the moderately high scheduled speed between the two stations. It is essentially to have high acceleration and retardation values. Okay, first of all, first one is urban or city services. In this type of service, there are frequent stops. Okay, the distance between the stops is less than 1 kilometers. That type of service is called urban or city services. Okay, in order to achieve the moderately high scheduled speed between the two stations, it is essentially to have high acceleration and retardation. And second one is suburban services. Okay, now the distance between the two stops is from 3 to 5 kilometers over a distance of 25 to 30 kilometers from the city terminals. Okay, in this case also high rates of acceleration and retardations are necessary. Okay, the distance between the two stops is from 3 to 5 kilometers. That type of services is called suburban services. So in this case also high acceleration and retardation values are necessary. Okay, and third one is mainline services. In case of mainline services, the operation is over long routes and stops are infrequent. Okay, now here operating speed is high and acceleration and braking periods are relatively less important. Okay, therefore the acceleration and retardation values are less compared to urban and suburban services. Okay, these are the types of services. First one is urban services. What is urban services? In this type of service, there are frequent stops and the distance between the stops is less than 1 kilometers. That type of service is called urban services. So in order to achieve the moderately high scheduled speed, the distance between the two stations, okay, it is essentially to have high acceleration and retardation values. And suburban services, generally the distance between the two stops is from 3 meters. Okay, and then in this case also high acceleration retardation values are there. And third one is the distance between the two stops is greater than 10 kilometers. And in this case, the stops are infrequent. Okay, so operating speed is high and acceleration and braking periods are relatively less important in case of mainline services. Okay, now what is acceleration and retardation? So first of all, acceleration. So acceleration is nothing but a direction of both velocity and rate of change. Same. Okay, direction of both velocity and rate of change of velocity are same, and the rate of change of velocity is called acceleration. Okay, so what is retardation? Direction of the velocity and rate of change of velocity are opposite to each other, and the rate of change of velocity is called retardation. Okay, what is acceleration? The direction of both velocity and rate of change of velocity are same. Here the rate of change of velocity is called acceleration. Now what is retardation? The direction of both velocity and rate of change of velocity in opposite to each other. Here the rate of change of velocity is called retardation. Okay, suppose the initial velocity is e, okay, in time t, and final velocity is v. So let us assume initial velocity 30 meters per second. Okay, initial time is 1 seconds and final velocity is 50 meters per second. So acceleration is equal to v minus u by t, that is equals to 50 minus 30 by 1, that is equals to 20 meters per second square acceleration. Okay, now what is retardation? Initial velocity u in time t, now final velocity is v. When it occurs, brakes are applied. Okay, so let us assume initial velocity 50 meters per second, time 1 second, and final velocity is, now the brakes are applied, the speed or velocity is reduced, therefore assume it is 30 meters per second. So retardation is equals to v minus u by t. So 30 minus 50 by 1 is equals to minus 20 meters per second square. Therefore retardation is equals to negative acceleration. Okay,
సార్ స్క్రీన్ షేర్ చేసిరా
కనిపించట్లేదా?
ఎలక్ట్రిక్ ట్రాక్షన్
No,
1 అని
sir.
మీరు ముందరికి వెళ్ళిపోతుంది -30 అవంతా లేదు, ఓన్లీ హెడ్డింగ్ ఉంది ఎలక్ట్రిక్ ట్రాక్షన్ 1 అని.
ఏది వస్తలేదా? స్ట్రక్ అయినట్టుంది, ఒక నిమిషం సెకండ్. ఇప్పుడు కనిపిస్తుందా? టైప్స్ ఆఫ్ సర్వీసెస్.
ఇప్పుడు కనిపిస్తుంది సార్.
Okay, types of services: urban services, suburban services, and mainline services. Next, acceleration and retardation. Okay, direction of, what is acceleration? Direction of both velocity and rate of change of velocity are same. Okay, here the rate of change of velocity is called acceleration. What is retardation? The direction of velocity and rate of change of velocity are opposite to each other. Now here the rate of change of velocity is called retardation. Okay, what is acceleration? First of all, initial velocity, let us assume it is equals to u, that is in time t seconds. Now final velocity v. So what is acceleration? V minus u by t. Now let us assume initial velocity 30 meters per second, in time period వచ్చేసి 1 second, final velocity 50 meters per second. Okay, now what is acceleration? Now acceleration equals to v minus u by t, v equals to 50 minus 30 by 1, that is equals to, what is acceleration? 20 meters per second square. Now retardation, initial velocity u, in time t seconds, final velocity v. So retardation equals to v minus u by t. Now let us assume initial velocity 50 meters per second, 50, final velocity is 30 meters per second. Okay, now let us assume retardation is equals to v minus u by t, v value 30 minus u is a 50 by 1, so is equals to minus 20 meters per second square, that is equals to, now retardation is equals to minus of deceleration, or sorry, minus retardation is equals to negative acceleration, as it is also called deceleration. Okay, so negative acceleration. Okay, okay, next one is the speed time curves for train movement. Okay, speed time curves for train movement. Now generally the momentum of trains and their energy consumption can be conveniently studied by means of speed time and speed distance curves. Okay, the momentum of trains and their energy consumption can be conveniently studied by speed time and speed distance curves. Okay, the name itself indicates, it gives the speed of the train at various times after the start of the run, and later gives the speed at various distance from the starting point. Okay, generally what is the main important of this speed time curve? Generally it gives the important points. First one is the slope. The slope of the speed time curve is gives the acceleration and retardation values. Okay, the slope of the curve will give the acceleration and retardation curve, and area, second one is area between it and horizontal axis. Okay, area between it and a horizontal axis represent the total distance traveled by the train, or the area of the curve. The area of the curve will give the total distance traveled by the train, and the energy required for propulsion can be calculated if resistance of the motion of the train. Is the main importance of the speed time curve. The slope of the curve will give acceleration and retardation values, and the area of the curve, the total area of the curve will give the total distance traveled by the train. It's a very important question for competitive exams. Okay, what is the area of the speed time curve will give the total distance traveled by the train. Okay, now this is the speed time curve. It is drawn in between speed versus time, speed in kilometer per hour and the time in seconds. Okay, now the main periods in the speed time curve is, first one is the following 5 parts. First one is constant accelerating period 0 to t1. Okay, constant accelerating period 0 to t1 or 0 to a is called constant accelerating period. And second one is acceleration on speed curve, that is t1 to t2 or a to b. Okay, third one is free running period, that is tt to t3, b to c. This area is called free running period. And c to d, t3 to t4 is coasting period. Okay, d to e or t4 to t5 is called braking period. Actually, it mainly consisting of the 5 parts. First one is constant acceleration period. Second one is acceleration on speed curve. Third one is free running period. Fourth one is coasting. And fifth one is braking period. Okay. Now first one is constant acceleration period. Constant acceleration period. During this period, the traction motors accelerate from rest. Okay, during this period the traction motors accelerate from rest. The current taken by the motors and the tractive effort are practically constant. Okay, during the acceleration period, that is 0 to t1, during this period traction motors accelerate from rest. The current taken by the motors and the tractive effort are practically constant. Okay, and this is also known as notching up period. This period is also known as notching up period. Okay, and represented by portion of OA. This period, OA period, is called notching up period or acceleration period. Okay, what happens in the constant acceleration period? During this period, traction motors accelerate from. కాకపోతే డిమ్ వస్తుంది. 1 second, డిమ్ వస్తుంది. ఇలా పడుతుంది అది. Okay, during the constant acceleration period, during this period traction motors accelerating from rest, and the current taken by the motors and the tractive effort is practically constant. What is the tractive effort అనేది నెక్స్ట్ వస్తుంది. Okay, okay, this is also known as notching up period. Okay, this is also known as notching up period, and it is represented by the portion of OA. 1 second, amma. చూపిపో చూపి మేడం, చూపి. ఒకవేళ ఓకే అనుకుంటే ఇది తీసుకుపో, మొత్తం డబ్బా తీసుకుపోయి అక్కడ పెట్టేసుకో. డ్రైవర్స్ వాడు వస్తాడు. The second one is acceleration on speed curve, that is T1 to T2. So after the starting operation of the motor is over, the train still continues to accelerate along the curve from A to B. Train speed increases as the speed is increases. Hence, acceleration gradually decreases till torque developed by the motor exactly balances that due to the resistance of the train motion. And the shape of the A to B of the speed time curve depends primarily on the torque speed characteristics of the traction motors. Okay, the curve A to B, the curve is mainly depends upon the speed torque characteristics of a traction motor. Okay, that is second period. Acceleration on speed curve, that is A to B or T1 to T2. After the starting the operation of the motors is over, the train still continues to accelerate along the curve from A to B. During this period, the motor current and the torque decreases as the train speed is increases. Hence, the acceleration gradually decreases till torque developed by the motor exactly balances that the due to the resistance of the train. Okay, the shape of the A to B. The shape of A to B of the speed time curve depends primarily on the torque speed characteristics of the traction motors. And next one is free running period, B to C. Okay, B to C or T2 to T3, that is called free running period. What is free running period? The end of the speed curve running, that is second period. At T2, the train attains the maximum speed. At the end of the acceleration on speed curve, the train attains the maximum speed. During this period, trains runs at constant speed attained at T2 and it's a constant power drawn. Therefore, it is a constant line. In this period, the trains runs with a constant speed. That's why it's called free running period. Okay. And next one is coasting period. That is T2 to T3, sorry, T3 to T4 or C to D. At the end of the free running period, the power supply is cut off and the train is allowed to run under its own momentum. Okay, the power supply is cut off and the train is allowed to run its own momentum. Okay, the speed of the train starts decreasing on account of resistance to the motion of the train. పవర్ సప్లై కరెక్ట్ చూడు ఎక్కడుందో. ఏం కావాలి నీకు? క్యాటరేజే కావాలా? వద్దంటున్నా? Next one is a coasting period. Generally, during the end of the free running period, the power supply is cut off and the train is allowed to run under its own momentum. The speed of the train starts decreasing in account of resistance to the motion of the train. The rate of decrease of speed during the coasting period is known as coasting retardation. Generally, it is practically that value is constant. Okay, coasting is desirable since it utilizes some of the kinetic energy of the train, which would otherwise it will be wasted during the braking. Hence, it helps to reduce the energy consumption of the train. Okay, generally it represented with the C to D on the speed time curve. Okay, what is the coasting period? During this period, power is cut off, train is allowed to run its own momentum. That type of period is called coasting period. Okay, and last one is braking period, D to E or T4 to T5. During this period, brakes are applied and the train is brought to rest. Generally, it is represented with D to E. Okay. That is speed time curve. It's a very important question. Speed time curve of a train momentum. ఇక్కడ మెయిన్ లైన్ సర్వీస్ కాదు ఇది. Speed time curve for train movement. Okay, first one is generally the curve drawn between speed versus time, and this curve is divided into the 5 following parts. First one is constant accelerate period, second one is acceleration on speed curve, third one is free running period, fourth one is coasting period, and fifth one is braking period. Okay, now first one is constant acceleration period. Generally in this case, in this period, traction motors accelerate from rest. The current taken by the motors and the tractive part are practically constant. Generally, this period is also known as notching up period. Okay, and second one is acceleration on curve. Generally, during this period, after the starting operation of the motors is over, the train still continues to accelerate along the curve of A to B. During this period, the motor current and the torque decreases as train speed is increases. Hence, the acceleration gradually decreases till torque developed by the motor exactly balances that due to the resistance of the train motion. And the shape of the A to B is mainly depends upon the type of the speed torque characteristics of the traction motor. Okay, and third one is free running period. During this period, train attains the maximum speed, therefore it runs with a constant speed. After the end of the acceleration on speed curve, the train attains a maximum speed. Therefore, in this free running period, train runs with a constant speed. And next one is coasting. At the end of the running period, the power supply is cut off and the train is allowed to run under its own momentum. Okay, the speed of the train starts decreasing on account of resistance to the motion of the train, and the rate of decreasing of speed during the coasting period. The rate of decreasing of speed during the coasting period is known as coasting retardation. Generally, the coasting retardation is practically constant. Okay, and last one is braking period. So, braking period, in this period, brakes are applied and the train brought to rest. Okay, that is speed time curve of train momentum. And the speed time curve for different services. So next topic is speed time curve for different services. Speed time curve for urban services, suburban services, and mainline services. So this one is a speed time curve for suburban services. Generally this is for urban or city services, and mainline services is same as this one. So mainline services కూడా ఇలాగే ఉంటుంది. Okay, 1 second. Next one is the typical speed time curves for different services. Okay, now first one city services or urban services. I draw a curve between first one is urban services. Okay, now this one is speed in kilometers per hour, and next one is time in seconds. So this is the acceleration period, and this is the coasting period, and this one is braking period. Okay, there is no free running period for urban services, urban and suburban services. It's a very important question. There is no free running period for urban and suburban services. Why? There is a frequent of stops. There is a frequent stops for urban and suburban services. And there is no free running period. అసలు మనకు ఏమవుతుంది, కొద్దిగా యాక్సిలరేట్ చేయగానే ఒక స్టాప్ వచ్చేస్తుంది. The distance between the two stops is very less than 1 kilometers. Okay, that's why there is no free running period in urban services and suburban services. Generally, this is the urban services graph. This is the acceleration period and coasting period and braking period. Okay, now city services or urban services, the relative values of acceleration and retardation values are very high. Okay, so these high acceleration retardation values are in order to achieve moderately high average speed between the two stops. Now due to the short distance between the two stops, there is no possibility of free running period through a short coasting period. Okay, there is no free running period in case of urban and suburban services, and there is no possibility of free running period through a short coasting period is included to save on energy consumption. Okay, next one is suburban services. Same rendu same untai curves, speed time curves, urban and suburban services. This look like a free running period. అందుకే రబ్ చేస్తున్నాను నేను. Okay, this one is coasting period. Now this one is acceleration. Now this is the braking period. Okay, similarly here also suburban services represented in which again there is no free running period, but there is a comparatively longer coasting period compared to urban services. Longer coasting period compared to urban services because of longer distance between the stops. Okay, in case also relatively high values of acceleration and retardation are required to attain the high schedule speed. Okay. Generally, the curve is similar to the urban services. Only difference is that longer coasting period. Longer coasting period ఎందుకు ఉంటుందంటే distance between the two stops is high compared to urban services. Similarly, ఇక్కడ కూడా high values of acceleration and retardation values are there. Okay. And third one is mainline services. So mainline services, speed versus time. Okay. Now this is the acceleration period. This is the free running period. This is the coasting period. Now this is the braking period. Okay. Generally, there is a free running period in case of mainline services, but there is no free running period in case of previous urban services and suburban services. And the values of acceleration and retardations are governed by the fact they should not cause discomfort to the passengers. Generally, it values. One second. And in case of mainline services, there is a long periods of free running at high speeds. In case of mainline services, long periods of free running period at high speeds, and the acceleration and retardation values are not important to achieve the scheduled speed. Okay. And what are the approximate values of acceleration and retardation for this urban services, suburban services, and free running period? Only the values of acceleration and retardations are governed by the fact they should not cause discomfort to the passengers. And the acceleration on suburban and urban services is varies between the acceleration on suburban and urban services in between 1.6 to 4 kilometer per hour per second. Okay. Generally, the acceleration for urban and suburban services is 1.6 to 4 kilometer per hour per second. The units which is very important for competitive exams. Acceleration and retardation values units are kilometer per hour per second. Okay. Now with the trolley buses, it varies from 0.4 to 6.5 kilometers per hour per second. For trolley buses, it varies from 0.4 to 6.5 kilometer per hour per second. Okay, the higher values being employed in generally in USA. Okay, and the coasting retardation is about the coasting retardation is about 1.16 kilometer per hour per second. Generally, it's practically constant. Okay, and the braking retardation values is in between 3 and 5 kilometers per hour per second. Okay, these are the acceleration and retardation values of urban and suburban services. Now, mainline services, it's not so important. Okay, acceleration values varies from 1.6 to 4 kilometers per hour per second, and the braking retardation is 3 to 5 kilometers per hour per second. Okay, and next some important definitions are there. Some important definitions. First one is crest speed or maximum speed. Okay, first one is crest speed or maximum speed. Okay, generally it is nothing but a crest speed or maximum speed attained by the vehicle during the run. The definition of what is a crest speed and maximum speed. Okay, the maximum speed attained by the train. The maximum speed attained by the train is called crest speed. Okay? The maximum speed attained by the train is called crest speed, and it is represented with VM, maximum speed or crest speed. Okay, and second one is average speed. And second definition is average speed. What is average speed? The distance between the distance covered between the two stops is divided by the actual time of run is known as average speed. Okay, what is average speed? The distance covered between two stops divided by actual time of run. Is known as average speed. Okay, what is average speed? The average speed is equals to distance between the two stops by actual time of run. Okay. Average speed is represented with VA. VA equals to distance between two stops by actual time of run. Okay, and third one is scheduled speed. Scheduled speed. Next one is scheduled speed. It is defined as the ratio of distance traveled, the total train, the distance traveled by the train by actual time of run plus time of stop is called scheduled speed. Okay, it is defined as the ratio of, it is defined as it is the ratio of distance covered between two stops and total time of run including time of stop. Okay, it is defined as the ratio of distance covered between the two stops and the total time of run is including the time of stop, and it is represented with Vs. Scheduled speed is equals to distance between two stops by actual time of run plus time of stop or stop time. Okay, that is called scheduled speed. It is defined as the ratio of distance covered between the two stops and total time of run is including the time of stop. It is called scheduled speed. Okay, three important definitions are there. So first one is crest speed or maximum speed. The maximum speed attained by the train is called crest speed and it is denoted with Vm. And second one is average speed. Average speed is defined as the distance covered between the two stops divided by the actual time of run, and it is represented with VA. VA equals to distance between the two stops by actual time of run. And scheduled speed. Scheduled speed is defined as it is the ratio of distance covered between the two stops and the total time of run including the time of stop. And Vs, it is represented with Vs. Vs equals to distance between the two stops by actual time of run plus time of stop. Okay, Generally, what is the schedule speed? Distance between the stops by actual time of run plus time of stop. Okay. And generally, the difference is for urban and suburban services is the scheduled speed is negligible in case of urban and suburban services. Okay. Now, what are the factors affecting the schedule speed? It is a very, very important question. What are the factors affecting for schedule speed? Okay. But in actual case, the schedule speed is always smaller than the average speed. It is also very, very important question. The scheduled speed is always less than the average speed. Okay. The scheduled speed is always smaller than the average speed. The difference is large in case of urban and suburban services, and it is negligible in case of mainline services. Okay. Generally, the scheduled speed is always smaller than the average speed. The difference is that larger in case of urban and suburban services and negligible in case of mainline services. Now, in order to have a fairly good scheduled speed for urban and suburban services, the stops must be reduced. Now, it is recommended to have stop time of 15 to 20 seconds. 15 to 20 seconds for small devices. Okay. And the scheduled speed of a given train when running on a given services and the distance between the two stations. With effective from with a given distance between the two stations, it depends upon the following factors. Okay, schedule speed is mainly depends upon the following factors. First one is acceleration and retardation. Acceleration represented with alpha and retardation, braking retardation represented with beta. Okay, acceleration and braking retardation values. Schedule speed is mainly depends upon first one is acceleration and retardation, second one is maximum speed or crest speed, and third one is duration of stops. Okay, the schedule speed is mainly depends upon, or the factors affecting the schedule speed is equals to alpha and beta, or acceleration and retardation, maximum speed or crest speed, or duration of stops. Okay, the factors affecting the schedule speed is a very, very important question. Okay, the schedule speed is mainly depends upon the following factors. First one is acceleration and retardation values, maximum speed or crest speed, and third one is the duration of stops. Okay, first one is acceleration and braking retardation. For a given run and with a fixed crest speed, the increase in acceleration will result in decreasing the actual time of run, and it lead to increase in scheduled speed. Similarly, increase in braking retardation will affect the speed. Okay, acceleration and retardation values for a given run and with a fixed crest speed, the increase in the acceleration will result in decreasing the actual time of run. Okay, it increase the scheduled speed. Okay, and the variation in acceleration and retardation will have more effect on scheduled speed in case of shorter distances when compared to the longer distances. And second one is maximum speed or crest speed. With a fixed acceleration and retardation for a constant distance run, the actual time of run will decreases and therefore scheduled speed will increase with increase in crest speed. Okay, now in case of long distance run, the effect of variation in crest speed and scheduled speed is considerable. Okay, and third one is duration of stops. The scheduled speed for a given average speed will increase it by reducing the duration of stops. Okay, and the variation in duration of stop will affect the schedule speed. Okay, more in case of short distances run in comparison to the long distances. Okay, the factors affecting the schedule speed is acceleration and retardation. Second one is maximum speed or crest speed, and third one is duration of stops. Okay, so next class lo the simplified speed time curves iddam. Okay na, simplified speed time curves. ఓకే, అందరు అటెండెన్స్ చాట్ బాక్స్లో పెట్టేసేయండి. Okay. ఎక్కడను